p-n junction diode. If one side of a single crystal of pure semiconductor Ge or Si, that is germanium or silicon, is doped with acceptor impurity atoms and the other side is doped with donor impurity atoms, a p-n junction is formed as shown in the animation. P region has a high concentration of holes and N region contains a large number of electrons. As soon as the junction is formed, free electrons and holes cross through the junction by the process of diffusion. During this process, the electrons crossing the junction from N region into the P region recombine with the holes in the P region very close to the junction. Similarly, holes crossing the junction from the P region into the N region recombine with electrons in the N region very close to the junction. Thus, a region is formed which does not have any mobile charges very close to the junction. This region is called depletion region. In this region, on the left side of the junction, the acceptor atoms become negative ions and on the right side of the junction, the donor atoms become positive ions. An electric field is set up between the donor and the acceptor ions in the depletion region. The potential at the N side is higher than the potential at P side. Therefore, electrons in the N side are prevented to go to the lower potential of P side. Similarly, holes in the P side find themselves at a lower potential and we are prevented to cross the N side. Thus, there is a barrier at the junction which opposes the movement of the majority charge carriers. The difference of potential from one side of the barrier to the other side is called a potential barrier. The potential barrier is approximately 0.7 volts for a silicon p-n junction and 0.3 volts for a germanium p-n junction. The distance from one side of the barrier to the other side is called the width of the barrier, which depends upon the nature of the material.